Hi, this is Lisa Knight, and this is the first of 4 lectures on rotational motion. So we've talked about kinematics, linear kinematics, and energy and momentum and forces and all the concepts related to things that are moving in a straight line. Now we're going to consider and just do a quick overview of rotational motion. In this video, we're going to start with rotational kinematics. So just like in regular kinematics, we have to measure the distance something moves. So in regular kinematics, linear kinematics, we measure the distance in terms of meters. But when we're rotating, we need an angular measure. The standard unit is the radian, and its symbol is theta. If theta is greater than 0, we're dealing with things that are moving in a clockwise rotation frame. But if it's less than 0, let me restate that. If theta is greater than 0, we're dealing with things that are moving counterclockwise. If theta is less than 0, we're dealing with something that is rotating clockwise. Remember that 1 revolution is 360 degrees. So if we wanted to convert that angular measurement then to distance, we would want to know the arc length S, which would just be equal to the radius R times the radians that you had swept out. When we talked about kinematics, we talked about speed in terms of meters per second. If we think about angular speed, instead of meters per second, it'll be measured in radians per second, or seconds to the -1. Also, since we're dealing with rotation, we would want to have some measure of time. And the measure of time we're going to use is the time for 1 period, t, or the time for 1 rotation, which can be found by taking 2 pi radians and dividing it by the angular velocity omega, which is measured in radians per second. The units of that period t will be seconds. And of course, just like in linear motion, acceleration is the rate that you're changing your velocity. Angular acceleration is the rate that you're changing your angular velocity or angular speed. And it's going to be measured in radians per second squared. And the symbol for it will be alpha. We could also rewrite our kinematics equations, replacing our V's with omegas and our A's with alpha. So you can take a quick look here. Instead of X, we are going to replace everything that has an X with theta, everything that used to be a V with omega, and everything that's acceleration with alpha. And remember, our units are going to be radians, radians per second, and radians per second squared. Now, when we talked about circular motion, we did talk about the tangential speed, which was basically the speed that it was traveling at, the distance over the time in meters per second. And that distance over time was equal to the circumference, 2 pi r, divided by the period for 1 rotation. But if we want to convert our angular speed to our tangential velocity in meters per second, all we have to do is take our angular speed of radians per second, omega, and multiply by the radius in meters. Our centripetal acceleration can be found by taking the radius times the centripetal speed squared. So radius in meters, and I said centripetal speed, but I meant angular speed, omega squared, radian squared over second squared, which will give us units of meters per second squared. And remember that when something is rolling, that tangential velocity is 2 pi r over the period. and it's also equal to r omega. So we have two formulas for tangential speed. Also, when things roll, it's not just, we have two things going on. The object is moving forward, so it has translational or linear motion, and it's also rotating. So it has two components or two parts to its motion. So it can get kind of complicated, and if you go in more detail and you're studying dynamics, which is the next level of physics or applied physics, then you would talk more about this.